And welcome back, George Noory with Brian Keating. He's got a couple books, including Into the Impossible. That's one. The other is called Losing the Nobel Prize. We'll talk a little bit about that in a moment. And his website is linked up at coasttocoastam.com. Brian, there are some that believe we're living in a simulated universe. And for years, I thought that was ridiculous. Now I'm not so sure anymore. What do you think of it?
Yeah, the simulation hypothesis is actually kind of proposed by a friend I hosted on my podcast named Nick Bostrom. He's a philosopher. And his essential argument goes like this: with the rapid pace of computer power, transistor number, and eventually memory and quantum computers, and then artificial intelligence, we're now able to effectively replicate the most complex dynamics, the physics of smoke and collisions and particles smashing together at near the speed of light in the universe as a whole. And then the question is, well, what do we like to simulate? Do we simulate, just a cup of water sitting on a desktop for hours and it's in thermal equilibrium? No, that's kind of boring. But we would simulate something like a massive explosion or collision of galaxies. So it tends to be more interesting to simulate more complex phenomena and more complex dynamics. In fact, you'll find thousands of times more simulations of galaxies colliding together or neutrinos passing through the human body than you will find of water in a mug just sitting on a table. So if you keep extrapolating that kind of logic, it seems to be that, well, perhaps, in the great distant future, there will be simulations of every individual, every human being. After all, what's more interesting and precious than a human being, and what we can do in our infinite capacity for curiosity, wonder, and imagination. Well, if you keep thinking like that, and you keep thinking that computing power is just going to keep growing, artificial intelligence will keep growing, then it may be that that already happened. And we experience these kind of the sensations and whatnot, but they're effectively just chemical reactions to stimuli, which are passed through chemical, synapses in our brain. And there's really no distinction between the chemical process to a physical materialist and the process itself. In other words, there's no notion of soul or self or identity. So according to people like this, there is no reason to suggest that we're actually who we think we are, and not a simulation. And how would we be able to tell? So it's an ancient question. I mean, it goes back to Rene Descartes and cogito ergo sum, I think therefore I am. And there've really not been very many satisfactory ways that you could test that simulation hypothesis. And as scientists, what we want to do is not prove a hypothesis, but we really go about disproving everything else. And what's left via Occam's razor will be likely closest to the possible truth. So yes, there are a great many people who think about this, and then the question of ethics and morality and all sorts of interesting things come up in that simulation hypothesis.
Well, you can't rule it out.
That's right. You can't really rule it out. I mean, you can say that it's implausible. You could say, well, who's running the simulation? Is that an entity? Is that an AI? Well, who created that? And you could make sort of logical suppositions and maybe lead to contradictions. And you may even be able to say, well, there are certain things that are so-called, continuous variables, like an angle it has infinite number of degrees and numbers between, say, 0 and 90 degrees. There's an infinite number of numbers. So how you would require an infinite amount of memory, for example, to simulate every trajectory of every meteorite meteor in the universe. So yes, that might be overwhelmingly difficult. And then you might have to wonder, well, why is it doing that? But I think, a lot of people point out, well, the same could be asked of the concept of God. And in fact, a lot of the same questions, I say, morality, ethics, etc. Does the master simulator of this program that we call consciousness, does he, she, it, they, whatever, do they have a moral obligation to us? And, I always answer that question, well, if it's true that we're all simulated, why are there so many Kardashians? Like, do we really need so many Kardashians? I feel like that might be a disproof of it. But you're right, we really can't prove it wrong or falsify the hypothesis that we are in a simulation.
Where does the multiverse theory come in?
The multiverse is a consequence. It's not really a theory, but it's a consequence of many, many different branches of the most interesting and cutting-edge physics. One such branch is called string theory, where we believe, according to string theory, that just as we can divide up a chunk of rock into smaller chunks, eventually into molecules, divide those molecules into atoms, divide those atoms into protons and neutrons, divide those protons and neutrons into quarks, we believe, according to string theory, that the quarks themselves, which were formerly thought to be indivisible, could actually be fractionalized and broken into even tinier things called strings, or sometimes superstrings. And the question of that reductionism leads to a notion of what's called the string theory landscape, meaning that how many different possibilities for different particles, for different manifestations of matter, it depends on a property of the underlying theory called the vacuum state. And there's effectively an infinite number of those things. So you come up with an infinite number of possible universes that we could live in. And that is a form of multiverse. Multiverse meaning multi-many, verse meaning effectively a universe. But when we grew up, you and I grew up, there was just one universe. We called that the universe. But according to many cosmologists, including as a consequence of the theory of inflation that my experiments aim to test, there is concomitant with that a multiverse. In other words, you cannot have these waves of gravity that suffuse the universe, traveling at the speed of light, emanating from the first trillionth of a trillionth of a trillionth of a second of our history in the universe. You cannot have that unless there's so-called inflation. Well, inflation itself requires a multiverse. In other words, there cannot be just a single universe. And therefore, what we think of as everything there is just everything that we could possibly see since the origin of our observable universe. But there could literally be a universe right next door, one light day away, and when your listeners wake up in the morning, we could announce, well, we bumped into that universe after waiting one more light day after the impending 13.8 billion years that led us up to this point. So yes, the multiverse is a core concept in many modern models of physics. That's what makes science so interesting. There's everything within physics. And I like to say physics is the most interesting of all subjects because it literally covers everything from astronomy to zoology, if you think about it. Everything that's made of matter is comprised of entities that are governed by the laws of quantum mechanics, high energy particle physics, gravity, electromagnetism. These are all physical forces. Where it gets messy and where I lose interest, George, is when you have to start dealing with personalities, psychologies, politics. I always say I love doing astronomy because no one wakes up in the morning and says, oh, I hate that Democratic constellation. Oh man, that Republican asteroid is really bad. No, it's politics free. It's a safe zone. And we need that. The species needs to have a place of relaxation where we can contemplate those great issues that make us uniquely human.
How close did you come, Brian, to winning a Nobel Prize for all this work you've done?
In 2014, on St. Patrick's Day, at Harvard University, an experiment whose predecessor, BICEP, that we spoke about, had been upgraded. Just like your iPhone or Android gets updated every year, we update our experiments too. And the second generation of BICEP, called BICEP 2, had detected what we thought were the exact hallmarks, the exact imprints of inflationary gravitational waves. These leftover fragments of shrapnel of the explosive origin of the cosmos. We claimed we detected it at a press conference at Harvard University. It was on the front page of the New York Times. It was on CNN, ABC, all these different institutions saying we had made perhaps the greatest discovery of all time. And that we had found not only that the universe began with a Big Bang, but we found the Big Banger, if you will. If you were religious, it was akin to understanding what or who put the bang in the Big Bang. What gave it the energy? Why did the universe start expanding? It didn't have to. It could have started off collapsing. It could have expanded at a very slow rate. But no, it expanded at this ultra-luminous rate. And so we came extremely close. And the thing that caused us to slip up, that caused me and my colleagues on BICEP at Caltech and Harvard and Minnesota and Stanford and elsewhere to lose the Nobel Prize, as is the title of my first book, was none other than the most common substance in the universe, dust. Little microscopic grains of dust, effectively micrometeorites. And I actually give away these meteorites on my website, briankeating.com, that your team is linked to. I give away meteorites every month. They're magnificent things, George, because they're actually fragments of the earliest moments of our solar system's history. They're older than the Earth. And these meteorites are able to encode the properties and the conditions of the early solar system. And that early solar system was a very chaotic place. It was filled with dust and boulders and asteroids, but it was also filled with a lot of tiny little grains of magnetized dust. When you get these meteorites from me, you'll find them, and they have magnetic properties. You can put them on a refrigerator magnet. They can attract a compass needle. They're incredibly powerful magnets, and they get aligned by magnetic fields, I should say. And so in our Milky Way galaxy, was a magnetic field. There is a magnetic field. Just like every substance we know in the universe we think, or every structure, from planets to people to birds to insects, they have some degree of magnetism. And so do galaxies and clusters of galaxies. And our Milky Way's galaxy caused an imprint exactly like the kind we would have seen if the universe began from a multiverse in this inflationary explosive origin. And that tricked us, George, into seeing what we really wanted to see. It's a very common bias in science called confirmation bias. When a scientist sees what he or she wants to see. Because I always knew, creating BICEP, that if we were successful, we would win Nobel Prizes. There was no doubt about it. And in fact, the publicity that we got right afterwards is proof of that. You don't get on the front page of the New York Times very often for scientific discoveries.
And not win.
Yeah, exactly. So, this was very painful because we had to retract, the discovery and say, after working with our competitors on a competing spacecraft called the Planck satellite, that we were wrong. We made a mistake. We didn't make a blunder. We didn't put our thumb in the viewfinder or leave the lens cap on the eyepiece of the telescope. No. We really did see an astrophysical signal of dust in our galaxy, which is cool and interesting. And some people spend their whole careers. It allows you to learn about our galaxy's history and the magnetic fields within it, etc., and how stars form. But it wasn't cosmological. It didn't originate from the Big Bang's earliest birth pangs. And so the story that I tell in my cosmic memoir called Losing the Nobel Prize is really a tale of, sort of humility, but possible humiliation. We came so close. And then right after that, George, right after that, a couple of months later, I got a letter, a mailed letter, if you can believe it, in my office at UC San Diego. And I said, Professor Brian Keating, we are writing you from the Nobel Committee. My heart skipped a beat. I was like, didn't you guys hear we kind of had to retract this discovery? You Swedes, you don't even remember? But I was like, maybe they made a mistake. Maybe they'll give it to me anyway. No, it said instead, Professor Brian Keating, we're giving you the honor of selecting and nominating winners of the Nobel Prize for next year. And George, I don't know if you can imagine the disappointment. Imagine if you're a car dealer, and somebody calls you up, you haven't made a sale in a while, calls you up and says, hey, George, I'm looking for a great car dealer. Oh, yeah, this is great. I'm going to sell some cars. Can you tell me your competitor's name and, how to find them on the internet? It was humiliating in some sense. But I went through the process of nominating people for the Nobel Prize in the year 2016. And that would have been potentially the Nobel Prize that my colleagues and I might have shared. And I found a disturbing set of kind of forgivable sins had been waged against this great man known as Alfred Nobel. One of the most interesting, creative, and fascinating characters in all of history, and really not well understood. People know his name from the Nobel Prize, but they don't know what a great man he was. He died childless. He never married. He gave his wealth. He was like Elon Musk times 10. He had hundreds of patents. And he was incredibly wealthy. They called him, one of the richest men in the world at that time. And by today's standards, he would be like a trillionaire because he invented dynamite. And that made him incredibly wealthy, but it also made him incredibly guilty. And that's a very common thing that happens in science. We create things of great power and great understanding, but knowledge, the word science.
Like Oppenheimer.
Exactly like that, or Einstein. The word science in Latin means knowledge, but it doesn't mean wisdom. And so there's a very big difference in my interviews. I've done interviews with 20 Nobel Prize winners on my podcast. And I'm always trying to see, is it possible, George, that you can have enough brilliance that you become wise? I'm not so sure. And so part of my investigations into the Nobel Prize's history was to dig up what Alfred Nobel wrote in his will. He died on December 10th, and that's every year when the Nobel Prizes are given out. Not on his birthday. It's given, with flowers taken from the place of his death or his burial. It's a very macabre kind of ritual. You have all these incantations and rituals. You have to bow down and get a gilded graven image of the patron saint of science, Alfred Nobel. And it's a wonderful thing, and it's a very difficult thing because it challenges the way that science is actually done. We teach students about it, but we never really teach our students the ethics of it. What do you do when you have to, retract a discovery claim that was on the front page of the New York Times? That's not something that you can teach in freshman electromagnetism. And so it's a great challenge to me, and it's a very interesting story about how science is done by scientists. And scientists, despite the stereotypes, George, we're normal human beings. And, there's an old trope about scientists. How do you know a scientist is outgoing? Because he looks at your shoes when he talks to you. And it's really true. We don't do enough communication. We don't share this wonderful story, this beautiful script that we've been given by Mother Nature or God or whoever you want to claim. That is the greatest story ever told, but we are some of the worst, script readers that there are. And part of my mission on my YouTube channel and my podcast is to show the human side of scientists and show that we're wonderful, fascinating, childlike people with a great deal of stories to tell.
I know you're a scientist, you deal with facts. What does your gut tell you about the Big Bang?
Well, that's a very, very thorny question because you're right. A scientist, I have to say things all the time that I don't go on belief. People have heard, I made a video once called, I don't believe in gravity, and that's because I have evidence for gravity. I have evidence for evolution. I have evidence for the Big Bang, but there always is the limitation that you must be humble. You must realize you can't see everything. Mother Nature lets you take a dance with her, but she won't let you lift up her veil and see what she really looks like. And I think that's sort of the most beautiful thing about science is you get more sort of enjoyment when you don't come to it with an expectation of what you'd see. So I did as a young man. I always wanted to win a Nobel Prize. I competed very desperately the way some boys compete with their fathers about, who was a better high school football player, a wrestler or something like that. My dad used to go to sleep every night listening to Art Bell and then later in his life listening to you. And we used to compete. He was a scientist and he never won a Nobel Prize. So I always wanted to win a Nobel Prize, and it encouraged me to best him. And the only way I could think to do that was to do something truly historic, which would be to measure the first moments of the universe's history. But I'm not really married to that idea that there has to be a singular point when time itself came into existence. It's such a mind-bending concept that part of me thinks, well, why couldn't there be a universe that existed on the Monday before our universe came into existence? There was a day, if you think about it. If we just keep counting back 24 hours at a time, then we'll come to some day when the universe began, and at least our observable universe began. We can see now, but there's no telling what lies beyond that. And I think that's what makes science so exciting. Don't come to it with preconceived notions, like raising your kids. If you say, I really want my kid to be this, chances are, A, they won't be that, which you want them to be, because they're going to rebel against you. But, B, you miss out on this beautiful notion of seeing what they become. So that's the way I kind of approach it now. I'm really, truly blessed to be able to do what I do. I'm paid by the state of California and the taxpayers out there to do what I would do for free. Don't tell Gavin Newsom that. He might take them off on it, but exactly. Yep.
In 2030, the early part, a telescope is going online in Chile called Magellan. What will that do for us?
That's a massive telescope. I've been there when they were constructing it, and it was like seeing an Aztec sacrificial altar. The platform of this thing the telescope is 26 meters in diameter. It's impossible to visualize how big this telescope is going to be. It's the good fraction of a football field. And when I was there, they were just building the pedestal, and they had to blow off the top of a mountain to build it there. They actually made room for 2 of these suckers down there, 26 meters in diameter, made up of a hexagonal array of 7 individual 8-meter telescopes. It's going to revolutionize our view of the universe if it gets built, George, because there's actually right now a great battle. There are many telescopes that are trying to be built. But the U.S. government is crying poverty, and it's really a shame that we might not have the money to build these telescopes in the northern hemisphere. Something called a 30-meter telescope, slightly bigger than that, obviously, and then the Giant Magellan Telescope, which these things cost now billions of dollars, and it would make Mount Wilson, it would make Hubble, and it would make all their heads spin, because back then you could do stuff with a relatively smaller telescope. And I want to just make a plea, George. I've always wanted to have merch. You have such wonderful merch that you're associated with, and I love, to be a subscriber to your daily show for 15 cents a day. But the one thing I kind of missed out on is building my own telescopes, but that's okay. You can actually buy a cheap telescope. I don't get any commission from this. Go to Amazon, go wherever you like, B&H. Buy a $50 telescope, and right from where you are in Los Angeles, because I've done it myself, you can not only see the same things that Galileo saw with a tiny 2-inch diameter telescope, $50, you can feel the same feeling that Galileo had when he first spotted the moons of Jupiter, the craters on our moon, and the rings of Saturn. There's nothing else like that in all of science, George. You cannot replicate what it felt like when the scientists discovered the Higgs boson. I'm sorry, you can't do it. It's completely impossible. But you can replicate the sights, but the emotions, the visceral feeling of discovery. And to you, George, it will feel like it did to Galileo. And that's what's magical about astronomy.
When I had my first telescope as a kid, saw the rings of Saturn, Brian, it's exactly the way you described it.
Those 4 little dots, sorry to interrupt you, George, but those 4 little dots revolutionized our view not only of astronomy, but of theology, of religion, because for the thousands of years leading up to that moment, humanity, the smartest minds in humanity, believed that the Earth was the center of the solar system, and the solar system was the center of the universe. Aristotle, and later the Catholic Church, they all believed that was true. But Galileo said, well, I'm sorry to break it to you, but there is apparently another center of the universe, and that's the planet Jupiter. So he didn't prove that the Earth went around the sun. He tried to do that. He failed. He's my biggest scientific hero, Galileo. He's such an incredibly brilliant and wonderful scientist, but human being and writer and poet, artist. But his discovery moved the Earth from the center of the universe like no other discovery before or since. And he did it with a tiny little telescope that you can get for $50 today, the equivalent thereof.
What did you think about the scientific value of rebuilding the Arecibo Radio Observatory in Puerto Rico using modern technology? I know that was an older facility, and that's one of the reasons why it kind of fell apart during the storms there.
Yeah, so the Arecibo radio telescope was about 100 meters in diameter, 300 feet or so in diameter. It was actually featured or played a big role in the James Bond movie GoldenEye when it's kind of used in reverse to shoot.
I remember that.
Yeah, to shoot energy into space, and to my knowledge, my friends who operate it never really used it for that purpose, but it was used to discover things related to extrasolar planets and so forth. There are no plans right now to do that. China has built a worthy successor to it. It's a 500 meter diameter, so 5 times the diameter, which means 25 times the area of that instrument. And since that time, astronomers have made great progress in what's called synthesizing an aperture. So rather than building say, a single dish that's 500 meters in diameter, you can take many, many smaller and therefore cheaper dishes and spread them out over the same area, and you won't get exactly the same data and quality, but you'll get a reasonable approximation for a thousandth of the cost of building such an instrument. In fact, that very technique was used in just the past 7 years to make the first image of the event horizon of a black hole. And that was something the Arecibo telescope could never do. So I don't think they'll rebuild it. There are plans to build other types of telescopes in Puerto Rico, but they wouldn't exactly replicate that wonderful past design. May it rest in pieces.
Brian, you talked a little bit about religion. Do you ever see the day where science and religion will shake hands?
You know, there used to be. Every scientist was religious. Galileo was incredibly religious, even though he's often portrayed as sort of an enemy or, being tortured for science. That really didn't happen. He had a lot of negative consequences of his own personality. He was very egotistical, and the church allowed him to publish his ideas, but not to publicize them to the common man and woman. And so he was allowed to publish them in Latin, which was scientific but not popular. And then he kind of got a little too big for his britches, and his final 2 books were published in Italian, and that was too much for the Catholic Church, who otherwise had treated him okay. But Isaac Newton, George, I know this is, a PG-13 show, so I'll keep it very clean. But Isaac Newton said his most proudest accomplishment was that he emulated Jesus Christ and that he never, shall we say, got married. And that was the only way he felt he could replicate what Jesus Christ, his greatest hero. And he had what we call the imposter syndrome. I've done a lot of research on this and gave a TED talk about this. The imposter syndrome plagues many, many people and scientists. And I think that the religion can teach science a lot, because religion teaches you to be humble. And science, though, gives you another attitude, which is to have a little bit of chutzpah or arrogance, of ego, because it's very demeaning and debilitating to do science if you think you're never going to succeed. And at first blush, it's very hard to do science. So I think scientists can learn a lot from religion, but there's an awful tension between them. And I'm not sure it's possible to resolve them other than to say that, each is sort of expertise in its own domain, and that there's nothing moral about science, there's nothing ethical about science. You can't learn wisdom from science. But, if you want your brain surgeon to have a lot of ethics and morals and so forth, that might be your decision, but you also want him or her to have a lot of knowledge. So they both have their role, and I think it's incumbent upon us to take the knowledge from scientists, but not their wisdom, and maybe look to faith-based traditions for where we get our wisdom from, but not our science.
I'd like to know the difference between someone who studies astronomy versus a cosmologist. In other words, the difference between the studies and the pursuits. Now, I'd also like your thoughts, and if I recall correctly, astronomers were the one that, with a lot of controversy, downgraded Pluto from a planet, which I think throws a lot of astrologers off, and people who follow astrology, because Pluto plays a very important role, particularly with its return to the U.S. chart coming up. And lastly, we've heard some people who go into telescopes, and we need more specifics, because I understand there's 2 types of lens other than $50, and I believe you said 2.5 inches.
Brian, astrology versus cosmology. About the same, isn't it?
No, well, astronomy is a vaster subject. And it is true. I often get asked, well, when people find out I'm an astronomer, they'll say, oh, that's wonderful. I'm a Virgo. What can you tell me? And I'll say, usually I would say, oh, I'm an astronomer, not an astrologer. They're very different. But now, George, I kind of have fun with it. I now start making up horoscopes for people. But astrology was the progenitor of astronomy. It really gave a lot of information, some data, some observational reading, just as alchemists played a role in the formation of modern chemistry. Now, cosmology is the study of the universe and its origin and its evolution. What is it made of? How old is it? How long will it live? Will it ever end? And those are very similar, related things. Astronomy is a more expansive subject, and cosmology is a subset of astronomy. And I should point out, the other thing, when I tell people I'm a cosmologist, they say, well, why is your hair so messy? But they have a relationship. The word cosmos in Greek means beauty or appearance. And so the cosmos to us is the beautiful appearance that's shown to us from the astronomical objects that we can see.
And how about Pluto as a planetoid?
Yeah, so Pluto was demoted in the early part of 2006 by the only union. I'm not big on unions, George, but I'm a member of the International Astronomical Union, and it's sort of a place where they make definitions of things. And Pluto had been a planet for 70 years exactly, since Clyde Tombaugh discovered it in Arizona. And that was really the case until the eggheads, my friends at the IAU, this union, said that a planet needs to meet 3 different criteria. It has to orbit the sun, which Pluto does. It has to have a nearly round shape, unlike an asteroid or the meteorites that I give away on my website. They don't have round shapes. They're not massive enough. And then the last thing is they have to have cleared the neighborhood where they orbit. So, since, as your caller pointed out, we haven't even been around, Pluto hasn't been around long enough for us to witness a complete orbit of it, although it orbits nearly in a circular shape, an elliptical shape, but it actually shares its orbit with other objects in what's called the Kuiper belt, which means that it hasn't really cleared out the neighborhood of the other debris and objects. It in fact has some moons and it has some rings as well. So it doesn't meet all those definitions, and there's a wonderful book by a friend and colleague of mine at Caltech named Michael Brown called How I Killed Pluto and Why It Had It Comin'.
The other one is telescopes. We know they have reflectors and refractors. What do you think?
The simplest one is just like a spyglass, a refractor. Those will get you basically 90% of what you can see. When you get a little bit more money, a little bit more familiarity, you'll get a telescope. Those can be much bigger for reasonable cost. The most important thing, though, is to just go out, look at anything in the night sky. Do not look at the sun, but any single object that you see, you'll want to research. And the only other thing I recommend your caller get is a $2 notebook to record what she sees or what her kids or her grandkids see when they look through it. That is what makes you a scientist. Recording your observations and then making up ideas and hypotheses about what you're seeing. And that will connect you to this great tradition going back to Galileo, the first person to ever use the scientific method. And what did he use the scientific method with? What tool? The telescope. Nothing else.
Brian, can we explain what nothing is?
Yeah, the nothing is problematic because it's not the absence of something. If you have just a completely empty box, it is not empty. It's a so-called vacuum. And inside of the vacuum, there is potentiality. Potentiality for what? For objects to materialize. You've heard of conservation of energy, which is the principle that energy cannot be created or destroyed. But there is no such principle of conservation of matter. Matter gets created and destroyed all the time, and thank goodness for that, because otherwise we wouldn't be here. So emptiness, nothingness, is not what we think of it. It has a very strict definition in physics, and it gives the infinite potentiality for matter, for energy, and for eventual expansion to take place in our universe.
And welcome back, George Norrie, along with Brian Keating. And Brian, I'd like to extend an invite to you to come back as often as you want.
That's a huge honor. I'm a big fan of you and Art Bell, of course. We used to go to bed listening to you guys every night.
Your dad's up there with mine. They're both listening together.
Absolutely.
You said something about everything's expanding away very fast pace. We could have been slow, but it's very fast and so forth. Then you talk about this space dust is magnetic and the meteorites are especially magnetic and all. So I must miss something here. In other words, if all that's going, how is this stuff coming back to us?
Yeah, it's a very good question. So you might think that if you have a lot of matter in the universe, that would actually cause things to kind of contract and pull closer to us. And in fact, none other than Albert Einstein felt the same way as you did in this question that you're asking. In other words, he wondered why the universe is the way it is. According to him, back in 1917, all we knew about was the galaxy, and the galaxy of stars moving towards us and away from us, but it wasn't expanding or contracting on the average. So he invented something called the cosmological constant, which was this fictitious substance that he claimed would counteract the pulling force that you talked about, the gravitational attraction of matter that we knew existed. He's made of matter, after all. The sun's made of matter, the earth. So something had to keep it from collapsing in on itself. And so he conceived of this term called the energy, or the cosmological constant. And later, when 1929 rolled around and Edwin Hubble showed his friend up in Mount Wilson, up in the mountains above Los Angeles, that the universe was actually expanding. It wasn't contracting and it wasn't static. Einstein said, "I have made the greatest blunder of my life." And what's so ironic is that not more than 75 years later, a team of astronomers from around the world discovered that the universe is actually filled with that same cosmological constant that Einstein thought about 75 years earlier, except he called it a blunder, and it was actually necessary. So I aspire to make a blunder which turns out to win people Nobel Prizes 75 years later. That's the greatness of Albert Einstein. So he had to conceive this type of force, this fluid that fills the universe and actually keeps it not only from contracting, but expanding at an ever-increasing rate, such that tomorrow the universe will be slightly more separated, diffuse, diluted than it is right now. And the question that we have is, what will happen in the very distant future? That's an open question my colleagues and I are trying to solve.
Brian, tell us about your relationship with Terrence Howard, the actor, who's got his own method of mathematics.
So Terrence Howard is a fascinating actor. He was in many, many movies and TV shows, ranging from Iron Man to Empire, Mr. Holland's Opus, I believe. He's just a phenomenal actor. He lives in Los Angeles. And about 2 or 3 months ago, he went on on the Joe Rogan Experience and made an appearance in which he had claimed to have over 90 patents to his name, and some of them for novel, if correct, mathematical, physical objects that could perhaps provide infinite, limitless geometrical functions and all sorts of things. And I had gotten kind of wind of this and heard about this because he was speaking about things related to physics, including the periodic table of the elements might not be, according to him, correct, and in fact must follow a spiral shape with all sorts of new elements and things within it. So this most controversial claim, though, is not the periodic table or even the properties of different drones and things that he claims to have invented, but he claimed that the number 1, when you multiply the number 1 times the number 1, it equals 2. George, he's not only proving, say, me or Albert Einstein wrong. He's trying to prove Euclid wrong. He's trying to prove the Greek mathematicians wrong. He's an incredible genius in a lot of ways. He's fascinating in his fearlessness and delving into topics, but I'm afraid he's quite off when it comes to both the assertions that he makes about chemistry and the periodic table, the properties of mathematics. We've had some back and forth. He was a little bit irritated at me in one of my videos that I made, not disparaging or ad hominem attack, but just displaying it, and he pointed out some errors that I had made, and I've corrected them, and it turns out he has some patents. I said incorrectly he has no patents. So he's just a fascinating, interesting individual. He's got a very big heart. His ideas, George, have been seen by 30 million people. We've agreed to get together, and he'll show me his laboratory, and I'll show him my laboratory, and may the best scientist win.
Why don't you get him and you two come back on the show?
That would be great. I'll propose that to him, George. Thank you.
Colleen in New Mexico, west of the Rockies. Hi, Colleen.
Hi. Since solar stars have certain jobs, like making black holes and nebulas and so on and so forth, can the gas planets be actual old stars? And at the same time, can there be a universal star that could create the universe but be that only one star nebulized?
Yeah, in one hand, your questions need to be framed in a proper scientific light. there is some truth to all of what you said. There are planets that are effectively failed stars. They're called brown dwarfs, and the name was coined by a famous astronomer named Jill Tarter, who was the inspiration for the character Ellie Arroway in the book Contact by Carl Sagan and his wife Ann Druyan, who I had on my podcast a few years ago. And this incredible scientist, she came up with this notion of the star that's not quite enough to engage in nuclear fusion at its core. It's not massive enough to compress it, but it's sort of, more than room temperature. So in that sense, yes. Now, we don't really think about them as creating things, but it is possible to take your analogy and think about, say, the properties of the Big Bang, for example. You talked about the universe or creating a universe. There aren't any structures that could, say, create a galaxy, an individual structure that created a galaxy. But if you think about the Big Bang, which we conceive of as the origin of all matter and even perhaps the origin of time, you might think about the universal singularity as what's called a white hole. Now, a white hole is sort of the concept that's a little bit different. Instead of everything that comes inside of its event horizon gets forever hidden away from observation by external observers like you and me, so it basically has a reverse of that, where everything comes out of it. Instead of everything getting sucked into it like a vacuum cleaner of sorts, inverse vacuum cleaner. And in that sense, you could think of the Big Bang as sort of that process. Now, it doesn't come from a star, and so you're wrong about that conjecture, but in some sense, it would be originating in that way. Now, there's a couple problems. There's no observational evidence for it. There's certain problems with the laws of thermodynamics, which we hold very near and dear. And lastly, we don't have a good theory of the quantum mechanical properties of gravity takes on the ultramicroscopic scales necessary to describe the conjecture that you made. But it's a very good series of analogies that you made, so thank you very much.
Let's go to Joan in New York. Welcome to the show. Hey, Joni.
Oh, hi. Yes, I have a couple of things. One, I missed the beginning explanation from Mr. Keating of why he had to retract the story, and George, you keep saying he then won the Nobel Prize. So if Dr. Keating, if you could explain that a little bit. But also, it reminds me of the stories that I heard about what politics is involved in the awarding of the Nobel Prize, which surprised me. I guess it shouldn't. But two examples, Jonas Salk never won a Nobel Prize for medicine. I can't imagine what anyone could have done that year that was more important than the Salk vaccine for polio. And apparently there was a lot of jealousy of him because he was one of the first doctors who became a household name. He was on TV, people knew him. I was 10 years old. I knew his name. Very important thing that he did. Made me feel very safe. There's of all people, Albert Einstein, who I was surprised to learn, did not win the Nobel Prize for relativity. He won it for the photoelectric effect. And the reason seems to be there was a French philosopher whose name escapes me, and he had a very public diss Einstein. They wrote letters back and forth publicly. Einstein claiming that you could use relativity theory to describe human relationships, aspects of human relationships. This philosopher was very put out about that. Didn't think that Einstein should be, nosing around in anything that wasn't physics, that human relationships was more the province of philosophy. And he had apparently some power to prevent Einstein the Nobel Prize for relativity theory. So that's, I guess, like three points I made, and I hope you addressed some of them. That's right, but you only had to retract your story.
Yeah, so the retraction came about due to the fact that we claimed we saw these waves of gravity percolating through the universe, but in fact what we had seen was an exact replica and an artifact, an imposter signal that was produced not by the origin of these waves of gravity, but by these micrometeorites, these tiny little grains of dust, like I say, a giveaway on my website. And these microscopic grains of dust or meteorites, if you win one, if you're one of the lucky winners, you'll see with a refrigerator magnet, they're highly magnetic. And our Milky Way galaxy has a magnetic field that produced a pattern of microwaves that exactly mimicked what we would have seen if the universe had an inflationary origin and came from a multiverse. So the reason that we among the, contenders for the Nobel Prize for the greatest discovery made perhaps of all time was because it proved not only waves of gravity for the first time existed in this way, but it also proved inflation took place. And lastly, it proved that the multiverse existed in some sense. So these are huge, huge things. So if we were correct, and we attempt to keep doing this now with the BICEP instrument, but also with the Simons Observatory instrument, which maybe we'll talk about some other time when I come back on, which aims to not only measure the cosmic signals, but also measure the dust signals. Now, as for the Nobel Prizes that you mentioned, Jonas Salk, yes, he lived a few miles away from where I am right now. And in fact, it used to be impossible for Jews like him to get, to own real estate in La Jolla and San Diego, until 1960, when Roger Revelle, founder of UC San Diego, said we cannot have a university without Jews. And so they allowed him to be a member here and to live here, and they retracted the covenant against Jews owning real estate, which is good for me because now I, as a Jew, can own real estate. And my house actually had a title that said you can't sell it to a Jew or black or a Mexican. And you can believe it. It was only 60-some years ago. And then last
Old times, weren't they?
Yeah, it really is. And then Einstein also, he was prevented from winning for a long time because he was a Jew. And real scientists, according to the German scientists that dominated early 1900s science Nobel Prize, real scientists were experimentalists that built hardware, apparatus. They didn't sit around lazily using just pencils and paper and thinking up experiments the way Einstein did in his mind. So, yes, there's there was anti-Semitism to blame for both of those, and it's just a shame that today there are a lot of biases that still take place. There's only been 5 women that ever won the Nobel Prize, no African Americans ever won the Nobel Prize. There seem to be a lot of barriers still left to break, and while the prize has a lot of good for the world, yes, there's been terrorists who've won it, the lobotomy won it around the year that Jonas Salk could have won it. And the Lighthouse won a Nobel Prize when Einstein could have been eligible decades before he actually won it in the 1920s.
Brian, keep in touch with us, all right?
I will, George. It's been an honor.